We have the big picture of domain-driven design already in our minds, so now it's time to get coding. You might think that since we are building a Firebase app, we will need to worry about using the Firestore and FirebaseAuth classes right from the very beginning. But that's not true at all with domain-driven design. Let's start in the most important layer of them all, the domain layer. Namely, we are going to tackle authentication in that domain layer. Hello, welcome to Reso Coder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In the previous, that means the first part, you could see the whole app, how it will look like and how it will work. And in the sign-in screen, these two fields are validated. When I try to sign in and there is nothing in these fields, we are going to get error messages saying that there is invalid email and invalid password. And when I write something in here which is still not valid email, still we're going to get this invalid email error string. But when I add the @ and some domain, that error message will go away. And the same goes for password. Unless it's at least 6 characters long, we're going to have an error. So let's try to implement this, not yet in the UI, but we're going to get this validation going in a domain-driven design way. But before we progress any further, I have a very important programmer and project safety announcement for you, so make sure you listen to it all. You are about to witness high amounts of abstraction throughout this tutorial series. Like with anything, pick and choose what you need and dismiss the rest. For example, you might want to separate your app into layers and use failures in place of exceptions. And if you don't know what I'm talking about, you should really watch the previous part. So you might want to do those things, but instead of utilizing validated value objects, to which we are going to get more in this part, you might want to validate data the usual way. So for example, in the presentation layer, because that's how you usually validate data. You don't usually validate data in the domain layer. Actually, the domain layer is usually not even present in your apps. So really, this tutorial series will follow the domain-driven design principles religiously to show you what's possible. But then it's up to you to choose what you deem to be an overkill and what you will actually use in your own apps. So no matter how you decide to build apps in the end, knowing domain-driven design will make you a better programmer who can look at problems from a new angle. So just don't tell me that this is completely overblown, this is an overkill. I know it's an overkill, and you don't need to use all of the things which I am going to talk about throughout this series. Really pick and choose what you want and dismiss the rest. Also, if you'd like to read this public service announcement once more and at your own pace, and also get all of the code written in this video together with the link to the GitHub repository for this project which we are building, and also for the fully finished project, so you can reference the finished app even before this whole tutorial series is finished, be sure to check out the written tutorial from the link in the description, where all of the links and all of the code is available for you. So how can we sign in using email and password? Well, the usual way would be to have a sign-in form that would validate the strings, and email addresses have to have the @ and basically the UI would look extremely like it would look the same as it looks now, right? But the difference is that in the case of our app, as you already know, the validation will not happen inside the presentation layer. No, instead we are going to utilize the type system and make validation happen in a type safe manner. So what do I mean by that? Well, Let's just imagine that we have a regular kind of code for signing in, and I'm actually just going to paste it into this main.dart file. By the way, we are inside a completely blank project, nothing is in here, we just have the main.dart file, and we're going to be adding our code to this kind of a blank project. So this is how usually you would have a sign-in method right over here. It would look something like this, right? So sign in, let's imagine that this is a FirebaseAuth method, and what you would usually do is you would pass in a string email and string password, right? This is what we are all used to. And this is all perfectly doable. We can call this method. We're going to do something a bit recursive right over here, because we are going to call sign in right from within the method itself. So because these two parameters of the function are just simple strings, what we can do right now is that we are going to pass in the email and initialize it to password, and the password can be passed an email. And this is something which we definitely do not want to let happen. It doesn't make any kind of sense. This data is invalid, but it's perfectly doable. Of course, we would still validate this data in the front end, in the presentation layer right here, but that would still not stop any incompetent programmer from messing things up later on once these strings are away from the text form field. So how can we go about preventing something like this from happening? How can we not be able to pass a string representing a password somewhere where there should be an email? Well, of course, the first thing we have to do is to ditch plain old strings in favor of some classes of our own. The first thing we can do is to create very simple classes, one for email address and another one for password. We're going to be operating in the domain layer, as you could have already heard at the beginning of this part, and we are going to separate our layers into folders. So every single layer will basically have one matching folder inside the lib of our Flutter app. So let's create a new folder for domain. And actually, while we are at it, let's also create all of the other folders. So we will have application, then also presentation, and lastly, we are going to have a last folder, which will be infrastructure. All right. Now inside this domain layer, let's create a feature folder for authentication, because after all, we are dealing with email addresses and passwords. So this should go over to auth, and inside this auth feature in the domain layer, we are going to create a new file for now called email address.dart. Inside of this file, we're going to create a simple class email address, which will simply wrap a string value, because email addresses are, after all, just strings. And since we need to populate this value, we're going to create a constructor for final fields. This can actually be a constant constructor. And if you want to learn more about what constants are in Dart, how to go about creating constant constructors and what all of that means, check out the tutorial from the card in the corner. And then lastly, we can add a bonus feature. Because we are using a custom class, we can add some sort of a null safety over here. So we can assert that the value which is passed in is not null. And with this done, we can now override a bunch of things over here, because currently the equality of email addresses is referential. So unless two instances of the email address class are not pointing to the same place in the memory, they're not going to be equal. But we instead want to have value equality, because two email address class instances which hold the same string value are of course equal. So in order to create value equality and all of that, I recommend using Dart data class extension, which you can get from the extension marketplace. So Dart data class right over here, this one, data class generator. So just make sure you get that, and with it, at least on VS Code, you are gonna be able to just control and dot or command and dot on Mac, as I'm currently on Mac, and you are going to say generate equality. All right, cool. Not quite, because it generated us also something for this assert, so it seems. All right, so we will need to do manual cleanup, unfortunately. Okay, clean this up, delete everything which should not be here. And now we have value equality comparing the string value right here. Additionally, we are probably also gonna want to override toString. So generate toString. Again, we have something which should not be here, unfortunately. We just wanna basically, yeah, let's just print out email address and then the value. Cool. So we have just overridden toString, hash code, equal operator. We are all good, right? Well, kind of. This is, of course, much more expressive than just having a plain string and passing that around, because, you know, if we have a function void f which accepts an email address, we are just not going to be able to pass in a plain string. We need to pass in an email address, whoops, which holds some sort of a string. But as you can see, we can now assign still any sort of a value to an email address. It's definitely not something I would call a validated value object. So we are getting somewhere, but we are still just at the beginning of making our types fully expressive. What we need to do is to validate whatever value is passed into the email address constructor. So usually, as I've already probably said 100 times, you are used to validating things as they are created in the UI. So we have a text form field right here, and when this text form field is populated with some value, you have some sort of a validator in the presentation layer, right? And the form can only be submitted when all of the text form fields are valid. And by the way, if you right now don't know what I'm talking about and you are still here, this is probably not a course for you. I do not mean it in any kind of a bad way, but really, if you are still here and you don't know about text form fields and forms in Flutter, really just go through some more basic stuff and then come back. You are going to be golden, but otherwise you're really not going to get much out of this course. With that said, we are not going to do validation in that manner. Instead, we're going to perform the validation logic inside our types. This way, we are going to make it possible to know that our types hold valid values throughout their lifetime, not just at the time of filling out a form, right? When this email address is gonna get into the layer where we are communicating with Firebase, actually, we are still gonna be able to tell that, oh, this email address is still valid. No one has been able to tamper with it. Because if somebody tries to put some invalid value into an email address at any point of time, at any layer of our app, it's still going to be not valid. We are not going to be able to use an invalid email address. We're actually going to implement all of this in this part. This is also called making illegal states unrepresentable. The most straightforward way of validating at instantiation time is to create a factory constructor, because inside some regular constructors it's quite tough to perform any logic. And then if the value is invalid, we're going to throw an exception. So let's do just that. We're going to create a factory email address, string input, and on this input we want to perform some sort of a validation, and also this constructor, which was previously public, will now be private after we remove this example function from over here. So let's make this just private with an underscore. And how are we going to perform validation? Well, we are going to separate out the validation into its own method called validate email address. Let's create it just below this email address class. It will return a string, which will be, in the case the string is valid, it's going to be returned. Validate email address. And it's gonna also have string input. And you may be actually used to this from the usual presentation layer. This is sort of a function you would put into your text form field for validation, right? So we are going to validate emails via a regular expression, and I'm actually just going to copy it over here from the written tutorial. So if you want to also get this kind of a regular expression, make sure to check out the written tutorial from the link in the video description. So here we have it. We have an email regular expression. This may not be the most safe email regex, but it's pretty good for our tutorial purposes. And now, usual stuff, we want to just validate a string based on a regular expression. So if regexp, the email regex string is going to be passed in, and if this regular expression has match on the input string, we're just going to return the input because it's valid. If you were in the presentation layer and you were creating a validation function, you would instead return null when something is valid, like this. But we have changed the rules a bit, and we are going to actually return the input itself if it's valid, right? And then else, if it's not valid, well, how can we communicate that it's not valid? Well, one option would be to return null, but I really don't like nulls because, yeah, they are not really expressive. You have to check for them all over the place. And even once non-nullable types are going to land in Dart, even then I would still not recommend really using nulls for indicating an error. So what we can do instead, at least for now, is to throw an exception, because that's probably the simplest solution, right? So we want to throw some sort of an exception. We're going to create a new implementation of an exception called invalid email exception. It will implement exception, and simply it's going to have final string failed value, so that we will know what the value with an issue is. And it's going to be populated in a simple constructor. And also, let's just make this a named parameter so that it's going to be easier to read the code later on at required. And let's also add the needed import here. Flutter.foundation. So with this done, we can now throw this exception, invalid email exception, from here and pass in the failed value, which in this case is input. So if the value which is passed in is, for example, something like ABCD, well, this is definitely not a valid email, so this ABCD value will be thrown as the failed value of an invalid email exception. So far, so good, right? So now we can use this validation function inside of our factory method. So what we are going to do in this factory is return and use the private constructor, email address, the private one, and we can just call the validation function right from the constructor parameters, because as you remember, this validation function returns a string, and this private constructor also accepts a string. So that's why we can call this method right from the constructor parameter parentheses. All right, and it's also not a bad idea to move this assert over to the actual factory, which is going to be called from the outside, and here we need to validate that input is not null. Cool. After we format this code a bit better, this is our current state of validating an email address, and you know, it kind of works. We are making illegal states unrepresentable, because if we create some sort of a test function here, so again void f, from here, if we want to create an email address, pass in some invalid value, what's going to happen is that the invalid email exception will be thrown and the email address will not even be instantiated. So yes, we are preventing invalid values from being represented by our email address class. The problem is in how we are preventing invalid values from occurring, because throwing an exception is probably, I would say, not the best solution. Why is that? Well, just imagine what you would have to do every time you instantiated an email address or a password or any kind of another validated value object for that matter. Well, you would need to wrap this instantiation in try-catch. So let's do just that. Try-catch, and actually we would need to catch just the proper exception because we are good programmers, right? We don't want to catch all exceptions. So on invalid email exception, catch E, and here we would do some exception handling, blah, 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 right? Write some code over here. And we would need to write this kind of a monstrosity every single time that we would instantiate some sort of a validated value object. And also, if we have more types of exceptions which can be thrown from a validated value object, we would need to handle them also, and we would need to remember or maybe check the documentation of that validated value object regarding which exceptions can be thrown. So for example, if we allowed only email addresses which are at most 20 characters long, we would also have an exception like exceeding length exception. I hope I spelled it right, but it doesn't matter. So catch E, right? And we would need to do all this crap for every single exception which can be thrown. And this is not something we want to do and keep in our heads to do manually. Our current troubles stem from the fact that the email address class holds only a single field, which holds only the correct value. But what if instead of throwing an invalid email exception, we would somehow store this exception also in the email address class? So we would have something like final invalid email address exception, or maybe just exception, right? Failure, let's just call it. And we would do something like this. But of course, storing exceptions somewhere is unconventional. So what we would do probably is, instead of having this as an exception, which is not actually thrown, which is kind of a anti-pattern, I would say, we would have a failure instead of an exception. It would not even implement exception because it's no longer needed. And we would be all kind of good, right? So invalid email failure. We would store this in the class. It's no longer being thrown around, which is a definitely good thing to see. We would then also need to populate this. So this.failure in the private constructor. And I'm not going to get into all of this code because actually we are going to do it in a different way. But something like this would be better than throwing exceptions, right? But if this was actually functional code, what we would need to do now is that whenever we had an email address, again inside void f email address e, what we would need to do is whenever we wanted to use that email address, we would need to remember to check if it's valid. So we would no longer do the try catch craziness whenever we instantiate a value. No, we would instead instantiate it as usual. But what we would need to do is whenever we want to use the value, for example, inside the UI, we would need to have if checks. So if e, which is the email address, let's actually rename it to be more something like email address, right? Because e is usually reserved for errors as far as I'm concerned. So email address.failure is null. Again, we are using nulls to represent if there is a failure or not, which is not a good thing. We would now be sure that if failure is null, that means that the value is valid. So we would be able to use the value, for example, to display it in a text field, right? This value is now sure to be correct. Otherwise, if the failure is not null, we would, for example, show an error snack bar, right? So we would need to remember to do these if checks every time we wanted to use the email address. And let's be honest, would we really remember to do these if checks if we were not forced to do them? I don't think so. We would probably just try to use the value and come up with some crazy stuff in order for not to do these if checks every time we want to use the value, right? So how can we make this better? Well, what if we joined the value and the failure fields into just one single field by using a union? And not just any sort of a union, but the either union. And if you are not aware, either is a union type coming from the darts package, which we are actually going to add to this project in just a little bit. And it's specifically suited to handle these kinds of failures. It's a union of two values, commonly called left and right, and the left side of either. So we are actually going to have either, it doesn't matter. We have left and right. So the left side is usually reserved for failures and the right side holds correct values. Before we add this darts package over to our project though, let's also think a bit about the failures. So we have a failure class right over here, invalid email failure. But what if we also wanted to have the exceeding string length failure, or maybe some invalid password failure, right? We now have two failures, but they are not related in any sort of way. And if we wanted to check through all of the possible failures, which can be thrown from some method, we would again, or not thrown, but return from a method, we would again need to rely on our brains to remember which kind of failures can be returned from a particular method. In other words, we would be in no better place than if we just throw exceptions. And of course, these failures would need to have a common abstract class, failure, right? Something like this. We'll be then able to implement the abstract class. And now we would be able to return both of these failures under their supertype. But again, we would need to remember about all of the subtypes of failure in our own head. So again, even for these failures, we are going to create a union type. And this way, we won't need to remember what kind of failures we have in our app by ourselves. Instead, the union type will tell us. Okay, so let's go to pubspec.yaml. And there are multiple options of which packages we can use for the regular union types. And in my opinion, the best option to use is freezed, about which you can actually also check out the tutorial separately from the card in the corner. So yeah, we're going to use that for the regular unions. We're going to paste the dependencies and dev dependencies from the written tutorial so that I don't bore you with writing them out. And once we save the pubspec.yaml file, all of the dependencies will be gotten for us. So the current versions, you can see them right now on the screen. And also the GitHub project will be perpetually updated from time to time, so that it will work with the latest versions of the packages. But of course, I cannot update the video, which is already on YouTube. So just make sure to check out the link in the video description, which is going to take you to the written tutorial on resocoder.com. And over there, you can have all of the links to also the GitHub repository. All right, we have darts for the either type. We have freezed for the regular unions. Let's jump back to our email address file, and we are actually going to create something for the union. So we are about to create a value failure. Let's do just that. There is a bit of boilerplate involved, but it's not too much. So abstract class, and also, by the way, you can create snippets for this, and the snippets are actually available from the written tutorial about the freezed package. So abstract class value failure is going to be generic. So the generic parameter will be t. We need to mix it in with _ $value failure t. And now we are going to have two union cases. One of them will be invalid email, const factory value failure dot invalid email. It's going to accept a string value failure, just like the classes which we are about to delete below. Cool. So add required. And we need to also specify the actual type of the class, which will be the freeze representation of this constructor. Yeah, that's just how this package works. So invalid email will be its name. And it's also going to hold the generic parameter t. All right, cool. Now we just need to mark this with add freezed, which is going to auto import all of the necessary stuff for us. And with this done, we can now actually delete all of the failure classes, which were here just for demonstration purposes. And what we can now do is to add freezed part statement to this file so that this class can have its code generated by the build runner. So we are going to create ptf. This is just a snippet I have. It's going to create part email address, which is the name of the file which we are currently in, .freezed.dart. And with this all done, we can now open up our terminal, and it just doesn't want to open up. So what's happening? All right. And we are going to write our favorite command, flutter pub run build runner watch, right? This is what we want. All right. So it's going to watch any changes in our file system, and it's going to perform the build every single time there are some changes. So what's going to happen now is that we are going to have a new file generated right below this email address.dart file. As you can see, it's right over here, and it holds our lovely value failure union. Of course, this union currently holds only one union case. And since we are going to also validate a password at the end of this tutorial, we are also going to create another union case for short password actually. So let's change also the class name to just short password and save it. It's going to get generated automatically because we are running the watch command right here. And now let's clean up our code, all of the mess which we have created previously in our email address for, of course, for science, for demonstration purposes. So we're going to create the failure field also from the private constructor, and the rest can basically stay the same. All right, so now comes the time to actually use the either union. So instead of having just a plain string value, we are going to have either, which comes from darts, as you can see right over here. And this will be either a value failure. So as you remember, failures are held on the left side of either. And this value failure will have generic type string, because also the input value is string. And then the correct value, which can be held inside either on the right side of it, is also string, because we are, after all, validating an email address. An email address is always a string. With this done, we are now not going to be able to use our current form of validate email address, and that's because it returns a plain old string. But the parameter of our private constructor is now not a plain old string, but instead it's either a value failure or a string. And this is perfect because that's precisely what we want. So let's modify our validate email address function to also return this either type. So let's copy it, paste it to be the return type of our validation function. And what we now need to do is that whenever this regular expression has a match in the input, which means that the email address is correct, we're going to return the input wrapped inside the right side of either. These are just top-level functions which come from the darts package right here. And in the other case, we are going to return value failure dot invalid email, and we don't want to throw it anymore, but instead, again, return in the regular flow of data, which is what we want from the very beginning. If you even remember in the previous part, in the first part where I elaborately explained the whole diagram, you could see that we actually do not want to use exceptions. We want to deal with failures which are returned and not thrown around crazily. So we want to return even errors, and we are getting there. So return the left side of either. Cool. Right side means correct data, which accepts a string, and the left side means incorrect, some failure happened, and this left side accepts a value failure. Cool. By changing the signature of the validation function, our email address now works. So now it's the proper time to explain how we would go about creating and using this email address. So let's again create a simple explanation function, void show the email address or failure, right? Imagine that this is somewhere in the UI or wherever. So we can create an email address very easily by passing in a string, right? This is obviously invalid, so this will hold the value failure and not the string. All right, so let's put it inside final email address. And how can we go about getting the left or right value from this variable? We have two options. So imagine that we are inside UI and we want to populate a text widget, something like this, right? So a text accepts a simple string, email text. And we want to get some sort of a string from our validated value object email address. The first way we can do it is by using fold, and this fold method will grant us two higher order functions which we can use. The first one is if left, and the second one is if right. And as you can see, this if left accepts the value failure, if right accepts the correct string. So let's utilize these two methods, left, which will be value failure, and we can say something like failure happened. More precisely, left, because this left is of type value failure. And then we also have if right function, which will pass us the correct value, so we can return right. Cool. So now we have this email text, which either contains some sort of an error message or it contains the proper value. This is the longer way to get the value out of our validated email address object. The shorter way is to use get or else in place of fold. So we're going to have again email address dot value, but we're going to say get or else. And what this does is that it's shorter, but we do not have access to the precise failure. So all we can do here is say some failure happened, but we are not going to have a clue about which precise failure happened because we do not have an access to the value failure object. Awesome. So what we've done up to this point is that we have a full implementation of a validated value object, namely the email address. But remember that we also want to validate other things. In this part, we are going to also validate a password. So we definitely do not want to copy or create all of this kind of boilerplate also in the password class. This toString, the equality, and the hash code can be definitely extracted into some sort of a abstract superclass. And because it's abstract and it's going to be used throughout multiple features of our app, we are no longer going to be operating inside the auth folder under the domain layer, but instead we're going to operate in a core folder. Core folders hold something which is common to multiple features in our app. So for example, value objects. .dart. This file will for now hold only an abstract value object class. So let's just actually copy this email address, paste it inside here. We're going to import everything from the appropriate file. All right. Let's also import value failure. But of course, we need to do some changes because this should be an abstract class and not a concrete implementation. So we're going to make it abstract. And the factory constructor nor the constant constructor will be here like this. Instead, we're going to have a const, not email address, but value object should be its name. And we are going to have a constant value object constructor, just a plain one right over here. We are inside an abstract class, so instead of having a final field, we can afford to just have a getter for the value. And then we also need to sort of modify these functions to work with any sort of a value object, right? So the first thing is that not every value object needs to necessarily hold a string. So we're going to make this generic, and instead of string, we're going to say t everywhere. This equal operator is not going to check if it's an email address, but instead a value object with generic parameter t. But then the value equality based on the value getter can remain here because this is still correct. And also the toString method will say value in place of an email address because email address doesn't make sense. And lastly, also, let's actually make this immutable so that we will enforce only final fields being present inside a value object. And just to clean it up a bit, I always like to put toString methods as the last in a class. Cool. So with this kind of an abstract class, which heavily relies on generics, we can now use it and extend the email address with it. So we are going to say extends value object of type string. Cool. And now we can actually remove the toString, equal, and hash code from the actual concrete implementation of email address, and it has immediately gotten a lot shorter, which is a good thing to see. So now we would be able to immediately create a password. But before we do that, let's just organize our classes and files a bit. So these feature-specific value objects will live only in one file. And because we are currently in the authentication feature, we're going to create that file under authentication. So it's no longer going to be an email address file, but it's going to also hold a password. So we are going to rename it to value objects under the authentication feature. Also, the part of the file will change to just value objects. Cool. And yeah, let's quickly also organize the validation functions, because we are also going to create another one for password validation. I like to put them all into the core folder. So even if they are used only in one feature, we are going to still put them into the core folder under value validators .dart. So let's paste that over here and let's import everything that's needed. Cool. And lastly, we have this value failure right over here. So what we are going to do is that we are going to put all failures under the core folder under the failures file. So failures.dart, paste that in here, and we are going to also provide the part statement for freezed. And let's save that. Let's also actually delete the part statement from the value objects under the auth feature. And let's now import all of the classes which are current right now from in a different file. Also, the validator is in a different file, so let's import that. Inside the failures, we do not have the require annotation imported, so let's take care of that. Let's actually import freezed annotation. Now save it. Everything's going to be generated nicely. And value objects now hold invalid import statements. How else? Because value failure is in a different file. And the value validators also hold invalid import statements. Woof! So we have organized everything properly, and now comes the time to actually finally create the password validated value object. So we are actually going to create the validation method first, or function, because it's top level function. So let's go to value validators.dart, and similar to how we have validate email address, we are also going to have validate password. So let's just copy the validate email address, change it to validate password. It's still going to accept string input. It's going to have string output, but instead of doing a regular expression check, we are just simply going to check only for the length of the password. So nothing fancy is gonna happen here. So if input.length is greater or equal than 6, then it's correct. Otherwise, it's a short password. And of course, you could add some advanced password checks. For example, if there is uppercase and lowercase letter, or if there is at least one number, but we are going to keep it simple here with just the length validation. So now that we have this validation function in place, what we can do is to jump back into value objects under the auth feature, and we are going to just copy this email address, paste it below, change email address to password. All right. Instead of validating email address, we are going to say validate password, and we are golden. So just like if an invalid email address string is passed into the email address validated value object, in much the same way when an invalid password is passed into this password validated value object, a failure will be instantiated instead of the correct value inside this value field. All right, so it took quite a long time to validate just two objects, right? We have just validated email address and password, and the raw video took me like over 1 hour to record. So yeah, but this is only because we have gone through the whole thought process of coming up with the best solution of making illegal states unrepresentable in Dart. Because as you could see, once you have everything in place, like we had after we finally organized everything into proper files and we had this email address here, creating a new validated value object is really just a matter of copying the previous class, or even writing it out manually, it's not that long, pasting it below, changing the validation functions which are called, right? Just adding a new value validator, which is really just a simple function. It really cannot get even simpler than this. And you can truly create a new value object in a matter of few minutes at the very maximum, even if you have some complex validation logic. So really, once you have all of the basics in place, it's very quick to progress in your app. But of course, when you are just learning, it takes quite longer to go through the process of coming up with the best solution to our problem in domain-driven design and validated value objects. And the best thing about having these specific value objects in places that would otherwise be just plain strings is that you cannot possibly mess up no matter how hard you try, because you just simply cannot pass a password to a function which expects an email address, even though they both wrap just plain strings. So to go through this tutorial at your own pace, once again, to get all of the code, check out the written tutorial available from the link in the video description. And in the next part, we are going to write code in the application layer responsible for gluing together the UI with the authentication backend. And I did not say FirebaseAuth. That's because, as you can imagine, we are going to use abstractions so that we do not have to rely on FirebaseAuth. So stay tuned for the next part and definitely subscribe to this channel if you do not want to miss it. And also, if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education. A link is also in the video description to get the top curated Flutter news and resources aimed at improving your app development career. And over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And again, if you do not want to miss the next part and also more tutorials like this, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you to understand a bit more how to do the domain-driven design style value objects, which are validated at their instantiation. Give this video a like and also share it with your fellow app developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video and in the next part of this tutorial series.